Hello everyone, in this video we're going to have a look at object-oriented programming. Now what is OOP or object-oriented programming? It is a way of programming that relies on objects and classes. What that means is that you have different ways of programming, which is, for example, the traditional way would be int x equals 9 and then you want to see out x, right? Or assume I want to write the code for a car, and then I would say the model would be 2024, and maybe you say string the name, or maybe not the name, the color is gonna be blue. Alright, assume that's a normal way of programming. Then you can just go see out these things, or you can pass them in a function, or you can play around with it however you want, make some pointers, stuff like that. But the thing is, you get procedural programming, you get functional programming, you get object-oriented programming. And now object-oriented programming is what says there is some languages, they support this type of programming, okay, like C++. C doesn't support it, C++ does. Okay, that's one of the main differences between the two. Now what object-oriented programming does is that you can take this and you can put it inside of a class. Okay, instead of making it appear in int main, or instead of it having in the having it available in a function, you can take the functions and you can take these data types of the variables and store them in a function. That's something you can do. Or no, not in a function, in a class. So that's what we're going to try to do right now. Okay, so I'm going to take this, I'm going to cut it out, I'm going to create a class, and after you write the class keyword down, I want to write the name of the class. So I'm not going to say class BMW, but I want this to be a generic class, so I'm not going to say BMW, I'm just going to say car. Okay, so I have a car called this. Okay, so model and the string k, which is blue. Now how would you access? Basically what this means is that you have a class car, okay, and that car has these variables inside of it. Now now the question arises, how can you actually access these variables inside of this car class? Well, the way you would do it is like this. You would say car, and then you would have a variable and then a semicolon. Now I'm just using x for now, just to indicate that this is a variable. Look, in C++ you know how to declare a variable, right? You have the int and then you have the model, which is, for example, you have the data type. Okay, the way you would do it in C++ is you would have the data type and then you would have a variable. Okay, so the data type, the variable, and then you can also have a semicolon, or you can have a value. Okay, but let's just keep it simple and have a semicolon. Now if you look at the parallelism between this and that, you would notice that this is actually the variable, this is actually x, and the data type is actually car, and that is correct. The data type is car, so car is a data type. Now what we done with the class is we actually created a new data type of our own. Instead of saying int x, string x, float x, bool x, we said car x. So x is now actually a car. It's not a int, it's not a bool, it's not a string, it's a car. We made our own variable. Now how would we actually access the model out of it? So the way to do it is we're going to say x dot model, and we're going to go ahead and see out this, so we can print it to the terminal. Now if I were to run this, what would happen is that it's gonna give us an error, and what this is saying is that it says that int a model is private. Okay, what's happening here? Well, in C++, alright, we have something called access specifiers. So they specify your access. You know, when you have access denied, right, with your fingerprints or biometrics and stuff, you have access denied. So that is the same thing happening here. You have access specifiers that specify access. Now in C++, what access specifiers do is that they show who can actually access the elements of a class. So who can access the model variable and the color variable inside of car. Okay, the class car. That's what we have to specify first. Now by default it's private. Okay, so we have three access specifiers in C++. One is called private, then we have public, and we have protected. Three of these. Okay, so now what private does is that it makes every element, everything inside of the class private, so nobody can access it. You can only access it within the class, but no outside the class. Like here what we're doing, we're printing out the model variable of the X class, then it's gonna say no, you can't do that because it's private. By default it's private. Alright, now what does public do? Public means that anybody can access it, and protected means that only some can, some can't. We're gonna get into the details of the protected later, but just for now, just know public and private. By default the access specifier is private, so we're gonna go with public now. So I would come and place public here and then a colon. What public does is that whatever comes after public would be declared public. Now I can also have private here. Now that means that whatever comes after private wouldn't be public anymore. It would be private now. Just watch out for that. Now that's something. Alright, now if I were to run the program right now, then you would see that it actually would print 2024, which is the model of the class, of the car. Alright, but now I'm not gonna say car X, I'm gonna go ahead and say car BMW. Okay, so because it's a variable, you can name it anything you want. So we run it again, and then you can see it prints 2024 is the model. So that's pretty much essentially what it is. And you can also have functions inside of car. Okay, so the way would be int, depending on if you want to return anything. I'm just gonna go ahead and create a function called print. Okay, so it's just gonna print all the contents of this. Alright, so I'm gonna go ahead and I'm gonna see out model, and then I'm gonna go ahead and I'm gonna see out an endl. Okay, and I'm gonna see out the color. Okay, so that's public, this is also public. So I'm just gonna go ahead and I'm gonna say bmw.model. I'm not gonna see out anything because I'm calling the function, it will see out. So I'm gonna say bmw.print, and you can see it's giving me this note that you want to actually use the print, and I say yes, and if I run it, you're gonna see that it actually prints out the model and also gives us the color of the class. Now that's what it is essentially, and I just wanted to draw your attention to something else before I go, is that if I were to remove this public, and if I were to run, not remove it, but take this public out, put it right over here, or not there, I'll put it at the end. Okay, and if I run this, then it's gonna give us an error. It's gonna say that these right on top of the public are private, so you can't really access them. However, if I were to put it here, public, alright, and if I were to run the program right now, then you would see that it actually works. But despite these variables being private, it still prints it, still accesses it, because the function, okay, accesses the model, it prints the model out. The function is public, but the model is private. So what private does is that it allows you to access the private members within the class. Okay, so that's what it is. It's private, but it is within the class, so it's allowed. However, you cannot access it outside the class. Now I'm just gonna you can also go ahead and, by the way, you can modify this. Okay, so if I were to delete print, I'm gonna say bmw.model is equal to, I don't know, maybe I'm gonna say 1999, and then if I were to say bmw.print, okay, now I'm printing all of that, and I made the model 1999. You can see that it actually prints 1999 instead of 2024. So you can also change variables like that. So that's what it is simply. In the simplest example we can go in object-oriented programming.